Guys, so in this video we'll be talking about projectile motion. So I'm pretty sure you all have seen what happens when you kick a football. So the football covers a path which looks something like this, right? Which is a parabola. Cool. So this is what is called projectile motion. Or in other words, you can say the path taken by an object in projectile motion would be a parabola. So moving in a parabola actually means moving in two directions. Okay, so this is completely different with from whatever you have done so far. We have learned about 1D motion, the Suvert equation, all that. We applied those in one directional motion, but here now the motion is happening in two directions. So let us talk about how do we deal with it, and especially in IB, to be able to solve the questions in the final IB exams, you must be able to know the concept in details, plus how to find out the maximum height, how would we know what will be the velocity in the y-axis after some time, what will be the range of the projectile. So you must master all these concepts if you want to answer your questions in the final exam. So here we go. Okay, cool. So now let us discuss that in detail. So what do I mean when I say it is a two directional motion? Okay, so let me explain it using this example over here. So you can see two cases over here. Okay, this is case 1, this is case 2. Case 1, in which I have a ball. Okay, I'm pushing this ball in the x-axis, like in the horizontal direction, and after some time this ball is reached to B and then it reached to C. So if I compare from A to B, the displacement of the ball when it reaches to B is this length, the yellow length, right? And if the ball reaches to C, the displacement will be this length, right? Is there any other direction in which the ball moving that you can spot? No, right? The ball is only moving in x-axis, right? Similarly, what happens if I throw a ball up vertically? So let us suppose I threw this ball was in my hand in the beginning. Okay, I threw it up, so it reached to, let us say this is, okay, let us say I threw it from here. Okay, this is the initial position A, the first ball. Okay, and then when I threw it up, after some time it reached to B, then C, then D. So if you see, if I see the displacement by this ball in the y-axis, so from A to B the displacement will be this height, right? From A to C, that means the ball has covered this height. From A to D, the ball has covered this height, right? So do you think, is there any other way, like in any other direction where the ball is moving? No, right? The ball only is moving in the y-axis, that means up. And in this example it is only moving forward. But now what if I throw this ball diagonally, as you can see in the picture over here? So moving diagonally means, like if I draw the arrow, in order to throw, in order to make it move like this, I have to throw this ball in this purple direction. As you can see, I'm drawing the arrow. So let us suppose the initial position is A, then B, then C. So from A to B, the displacement is this. Now you must be thinking that this displacement is only in this direction, right? The direction that I'm drawing. Then from A to C is this yellow line, right? But let me tell you, this diagonal direction is actually the combination of moving forward as well as up. Let me show you how. Okay, so now let us compare the positions of ball after some time. Initially the ball was at position A. Okay, I'll compare from A. Now let us compare the position B of the ball from A. So you see the ball has moved forward, right, as well as up, right? So the ball has this much displacement in x-axis and this much displacement in y-axis in order to reach from A to B, right? If I compare A to C, the ball has basically moved this much length in the x-axis. See, from C point is this much far away from A in the x-axis and this much high in the y-axis, right? If I compare another point D, you would see the distance in the x-axis will be this purple line, right? And the displacement in the y-axis will be this sky blue line. So you see it is keep on changing. So actually whenever you move diagonally, diagonal motion, I can say, is the combination of moving forward and upward together. When you move forward as well as up, as a result you go diagonally. Okay, so I can say that the projectile motion is as a result of moving in two directions. Now because I'm moving in the two directions, I need to know the exact details of both the directions in order to be able to solve these questions. Okay, so now let us take an example of the ball. Let us suppose I kick this ball, okay, in the direction of the yellow arrow. I give it a velocity u, let us say, which makes an angle theta from the ground. Okay, so of course now if I kick it in the direction of u as shown by the red arrow, the object is gonna follow this dotted path, right? Cool. Now so far we know that this dotted path is a result of moving in the x-axis as well as in the y-axis. So if you are moving in the x-axis, you must have some velocity in the x-axis, right? And you must have some velocity in the y-axis also. So how to know that? For that I need to split my vector. I need to split this u into x and y component. Sorry. So for that we have already learned vector splitting. So let me split this vector into x and y component. So one component, like my horizontal component, which is my x component, will be this purple line, and my vertical component, which is the y component, will be this sky blue line, right? So if I use basic trigonometry, let me call it uy for the vertical component and ux for the horizontal component. So if I use basic trigonometry, I will get to know that ux will come out to be u cos theta. The value of ux, which is my x component of velocity, comes out to be u cos theta. The velocity in y-axis, which is uy, comes out to be u sin theta. Okay, so once I know this, I no longer refer to this red arrow, because now I exactly know that this u cos theta is making this ball move forward. Meanwhile, this u sin theta is taking this ball up and down, and combinedly both are giving me a result of this parabola. Okay, cool. So let me draw these arrows at different positions, so I can draw my x velocity as u cos theta everywhere. So this u cos theta is taking this ball forward. Nothing else is responsible to take this ball forward. U sin theta has to do nothing with the motion in the x-axis. Okay, similarly u cos theta has to do nothing with the motion in the y-axis. This u cos theta's work is to make it move forward. That's it. Okay, so everywhere it is u cos theta. Now what about the velocity in the y-axis? Okay, so for that, as it is moving up, so you see the ball first is moving up, reaching at a maximum height, right? Here it is reaching the maximum height, and after that you see the ball falling down. So definitely the direction of motion is changing in the y-axis, right? As well as here the velocity becomes 0. At the maximum height the velocity becomes 0. So let me explain you this in giving another example. So what happens when you throw something up against the gravity? When you're throwing a ball up, as the ball keeps going up, it slows down, its velocity decreases, right? Why this happens? Because you're going against the gravity. Gravity pulls you down, right? And you move up, so your velocity keeps on decreasing and becomes 0 exactly at the top, right? It has to become 0 at the maximum height, because if it will not become 0, why will it come down? It will still keep moving up, right? So it will keep, so I can say in other words, the ball will keep going up until its velocity in the upward direction becomes 0. Once this happens, then the ball starts moving down, and while the ball starts moving down, the velocity keeps on increasing, because now you are moving in the direction of gravity. Okay, and just before hitting the ground, your velocity becomes maximum. So same thing happens here. Now this u sin theta, which is responsible to take you upward, is actually under the influence of gravity. So as you keep on moving up here, this u sin theta will not remain u sin theta anymore. It will keep on decreasing. So I'm drawing shorter and shorter arrow, and exactly at the top it will become 0, and then it will keep on increasing in the y direction. Okay, cool. Now let us quickly talk about u cos theta. See, you see that I have drawn u cos theta same for all the positions. This is because of one assumption, that we are assuming there is no air resistance. Okay, so if there is no air resistance, there is no force in the x-axis which is like pushing it back. Okay, there is no other force, there is nothing to decrease this velocity. Okay, so the velocity in the x-axis, which is u cos theta, this remains constant. Okay, and if this velocity remains constant, that means your acceleration in the x-axis is 0. Your motion is not accelerated in x-axis. Meanwhile, in y-axis, your velocity keeps on changing. It decreases first, becomes 0, and then increases, right? But in and that happens because of gravity. So in the y-axis, the motion is accelerated motion, and the motion is constant. Sorry, the acceleration is constant, right? So you can call it uniformly accelerated motion. And because it is uniformly accelerated motion, now I can very well use equations of motion for y-axis. Okay, equations of motion are only applicable for uniformly accelerated motion, which is happening over here. So for anything that I want to find out for the y-axis, I can use Seurat equation. And if I want to find anything for the x-axis, I don't even need Seurat equation because there is no acceleration. So I can simply use speed equals distance over time. That will simply work for x-axis, but it won't work for y-axis. Okay, cool. So now let us begin with our task. Okay, so my task 1 is I'm having this projectile motion, and I already know now my u cos theta is same for all of these, right? For at any position, u cos theta does not change, but you saw that u sin theta kept on changing, right? So now the first task only is to find out what will be the the y velocity after a time t. That means I want to know vy after a time t.